now let's talk about confusion matrix. So confusion matrix is for a model where the outcome is binary. Okay, so the outcome can be either positive or negative. Okay, so let's think of a case like the model is trying to identify spams. Okay, you provide it with emails and it is going to tell if it's a spam or not. Okay, so if it provides an outcome like positive, that means it is identifying the mail as spam. If it's saying negative, that means it is identifying the mail as not spam. Okay, so now what the model predicts and what the actual value is. Okay, so based on that, there can be four cases. Okay, the first one is model predicts positive. Okay, and actual is also positive. Okay, that means your model identifies it as a spam and it's actually a spam. So that is going to be true positive. Okay, the next one we see the true negative. Okay, so model predicts is as a not spam and actually also it's not spam. Okay, so these both are rightly identified. Okay, now there can be case like where the model is not able to identify correctly. Okay, so there can be two cases. So either it's a spam and model says not spam. Okay, so that means false negative. And the other case is it's actually not spam, but model identifies it as spam. So that is false positive. Okay. So this true positive, false positive, and true negative. Okay. The first part of it, the true, is like if the model is identifying correctly. Okay. True means a correct, you can relate it like a correct identification, and false is like incorrect identification. Okay. So now, based on this true positive, these all four metrics, okay, we have some calculations. We don't need to exactly remember these formulas, but we just need to know how it works. Okay. So precision, first is the precision. So precision, if you see, it's the true positive by true positive plus false positive means this one. Okay. So if we see this one, that means what is the common thing here? The common thing is in both case the model predicted as positive, right? So it's like you can say it like accuracy of positive predictions. Okay, that is like out of the all positive predictions, how many were correctly identified? Okay, so that's the precision. Next one is true positive rate, and this is also known as recall or sensitivity. Okay, here we have it like true positive, okay, and divided by true positive plus false negative. That means this case, okay. And this one is like, so the common thing if you see here is actual is positive. In one case, model is able to predict correctly. In one case, model is not able to predict correctly. So this TPR is basically how many of the uh, how many of the spams, you can say in our case, how many of the spams it were able to correctly identify. Okay, of the total spams which you are getting, actual positive means it was actually a spam. Okay, of the total spams, how many of them was the model to able to identify? Okay, so this is your true positive rate. Next is the false positive rate. Okay. Again, this is like false positive and then false positive by true negative, this case. So this is like you can say the actual is negative in both the case. That means it's a not spam. So how many of the total not spams the model incorrectly identified as a spam? That is your false positive rate. Okay. Again, saying we don't have to remember these things at all. Okay. Now there is a F1 score. F1 score is basically the precision and recall you already calculated, right? So this is a kind of a mean of them. Okay. Again, no need to know the formula. Just remember F1 is kind of a mean score, and this score is actually you can say your model score. This mean is actually like hold some importance. Okay, kind of a average model performance score if you want to say. So then we calculate it using the F1. Okay, so if the F1 score is high, that means your model is having a better performance. Okay. Okay. Any doubts up to now?
No issue.
Good. Okay. So now in the model parameter, there should be option threshold. Okay. The threshold should be between 0 and 1. Okay. What is this threshold? So whenever your model is predicting something as a spam, okay, it would give you a confidence score. Okay. You provided it with an email and it is like 90% sure that this is a spam. Okay. Then your confidence would be zero point 0.9. Okay. So similarly, it can be the confidence can vary from 0 point means 0 to 1. Okay. Now, when the confidence is varying from 0 to 1, you have it's in your hand to set up that threshold that on what confidence we are going to say that it is a spam. Okay, so that you can set up on your own the threshold. So if you have set up a threshold, let's say 0 0.6, okay. So anything which is identified as a spam but having a confidence less than 0.6 will be identified as not spam from the model, will be identified as negative from the model. Only if it's having a confidence higher than 0 0.6, then only it will be marking it as a positive, as a spam. Okay. Now, an important curve is there, which we call as ROC, Receivers Operating Characteristic Curve. In this curve, on the x-axis, we are going to put the false positive rate that we have seen earlier. And on the y-axis, we are going to put the true positive rate that also we have seen earlier. Okay. And then, like, if your threshold is fixed, right? Then the false positive rate will have a value and true positive rate will have a value. So if you are going to put it to your graph, it would be a single point you will be getting, right? But if you vary your threshold from 1 to 0, you are going to get a graph of this false positive rate versus true positive rate, which can look something like this. These are like three graphs for three different models, okay, which will look like this, okay. So it will always start from 0, 0 and always end at 1, 1. Why is it like this? Because if our threshold is 1, that means 1 means in a real world model will never give you a confidence of 1. It can be like 0.9999, but it cannot be 1, right? So that means none of the mails you can say will be marked as a spam. So you will be having a zero positive from zero positive outcome from the model. Okay. So since this is a zero positive, so the false positive rate, which was uh, false positive divided by something, and true positive was like true positive divided by something, right? So both will be zero. So that's why it's 0, 0. Okay. And if if your threshold is set to zero, that means with a confidence of zero also it will identify it as a spam. So that means all the outcomes will be positive only, right? So there would be no negative. So that's why if you again calculate this false positive or true positive, since there is no negative, so it would be like false positive divided by false positive plus true negative. So that is like true negative is zero. So that means it's false positive by false positive, that is one. Similarly, for true positive, it will come at 1. Okay. So in case of your threshold is 1, it's always 0, and in 0, 0. And in case your threshold is 0, it will always be 1, 1. Okay. The main curve draws between this thing when it varies from 1 to 0. So here we have the curve. Okay. And it's going to be it cannot go like this. Okay, it will be either a straight line from here to here. That is actually the worst case, and it can only go up. Okay, why it cannot go? If you want to deep dive into it, you have to apply some mathematical brain and think why it cannot go beyond this. Okay, but this is how it is. Now, the very important concept, this ROC curve is something that we just see. Okay, but from the exam perspective, the important thing would be the AUC, area under the curve. So the area which is below this curve, okay, that's the important concept, and that's the important model performance parameter. Okay, so area under the curve in the worst case, it would be 0.5. Okay, if you calculate it, so it's a triangle. The worst case I said is this one. So in this case, what is the area under the curve? 1 by 2 into this. So 1 by 2 into 1, that is 0.5. Okay. And in the worst case, this area under the curve will be 0.5. And in the best case, this can approach almost up to 1. It cannot be actually 1. This is wrong here. It cannot be equal to 1 or 0.5. It can reach up to 1. Okay, in the best case. So this is like area under the curve is measured how well the model is performing. Higher value means better model.